This is 7th grade lesson 3.8 activity. The objective for this activity is students will investigate what it means for two quantities to vary inversely. The standard covered in this lesson is 7RP2A. The page numbers out of the hardcover book are pages 142 through 147, and out of the practice journal, pages 83 through 86. So for this lesson, you're going to need your practice journal, and you're going to need to open up to page 83. On page 83, you will see something similar to what I have here on the screen. It's just that yours is in black and white, and part of my B is filled out. So there are nine ways to arrange 36 squares to form a rectangle. Here are two of the ways that you can find, and then we're going to go ahead and find the other 7. So what they're talking about in this little chart in letter B, why they have part of it filled out, is they just filled out based on what pictures we currently have here on the screen. And you'll notice that on these, on the first one that's on the left-hand side of your screen, you have where you've stacked 4 blocks high and 9 blocks across. And that used up all of our 36 blocks. So here they went through and they wrote out 4 for the height. The base was 9. And then we went ahead and filled out our little area equation. Area, which is what A stands for, equals our 9 times 4, or you could have written it out as 4 times 9, which gave us the 36 blocks total that we used. So remember, our area of a rectangle is base times height. So they went ahead and did the same thing with the second one that you see on the right side of your screen. Only this time the height was 6, and then they were able to stack 6 across. So they wrote 6 for the height, 6 for the base, and the area is 6 times 6, which once again gave us the 36 blocks. So we're going to go ahead and you guys are going to fill out your chart as I fill out my chart. So if you notice, why don't you go ahead and on your chart on page 83, jump down to the 4th and 5th boxes and fill in these. Okay, so I'll give you about a minute to do that. And if for the area part you just want to write 36 in that block, that's okay. Okay, so we'll go ahead and start filling out the rest of this chart. It says order the 9 ways according to height. Record your results in a table. So we're not just going to randomly throw out numbers. We're going to start with our smallest height. So the smallest height we could have would be to have actually just 1 block high, which means then for the length, like here we had a length of 9 or the base of 9, we'd have to go 36 across. And then to get our area, 1 times 36 would give us 36. Okay, so our next height, well, could we use 2? Would 2 go into 36? Yes, so that means that 36 is divisible by 2. So we could have where we had 2 blocks high. But then in order for us to get 36 blocks, we would have to take 36 divided by 2 and have actually 18 across. So 2 times 18 would give us 36. Okay, so what I would like you to do is go through and finish filling out this chart. Okay, and then we'll discuss the questions on page 84 in just a moment. So go ahead and pause your video and finish filling out the rest of the chart on part B, and then check back with your answers in just a minute. Okay, so you'll notice that as we went through these, we worked in our height going up from 1 through 36, only using the numbers that were divisible because we could not go through and actually use like half blocks. So that's why all of our numbers were whole numbers. So we used any number that would go into 36 evenly. Okay, so now at the top of page 84, you have these same questions that you see at the bottom of my screen. And it says, look at the first and second column. So we're focusing on our height column and our base column. And it says, complete each sentence. When the height increases, so as this column increases, and we get bigger as we go down from top to bottom, what is happening to our base? the base does what? What's happening to our base numbers? They're decreasing, right? As we went from 1 to 36, but then when our height went to 2, our base went down to 18. So this would be decreases. Okay, so then it says when the height decreases, the base does what? So now looking at this, we're going to look at our height in reverse. We're going to look at it from bottom to top. As this number goes down, 36 to 18 to 12 to 9 and so forth, what is happening to these numbers here? We go from 1 to 2 to 3 to 6 to 9, so they are increasing. Okay, and that's what's important to understand because that is showing us an inverse variation. So we're going to discuss a little bit about what an inverse variation. It says the relationship between the height and the base is an example of an inverse variation. You can describe the relationship with an equation. Our height is equal to 36 divided by b, which stands for base. So if we had 36 blocks and we set up for our base, just let's jump back to our little graph here. If we set up for our base 4 across, okay, then that means that each of our height would be to go 9 high on each of those. So you'll notice that an inverse variation is going to involve division, first of all. You'll see division when you've got that. In this case, we have h by itself, but we'll be working with y and x in the lesson as we work through inverse variation. And h and b are inversely proportional, which means as one got larger, the other got smaller, or vice versa. As one of them got smaller, the other one got larger. So that's working inverse variations where they go in opposite directions in terms of amount. Okay, so now go ahead and look at the bottom of page 84. And in your book, it says to work with a partner. Well, we're going to go ahead and kind of discuss these out together. So it says, look at each description, tell whether the two variables are examples of direct variation or inverse variation. So inverse, we just found out they go opposite. So inverse is opposite. I don't know what's going on with my smart board there. And then direct variation means that they're going in the same direction. My smart board, for some reason, is jumping all over the place. Okay, so we're going to go ahead and look at this first example. So we'll discuss out whether it's direct or inverse, and then we'll kind of give some examples for a table, and then we'll also write an equation. It says you bring 200 cookies to a party. Let n represent the number of people at the party, and c represent the number of cookies that each person receives. So let's go ahead and just do an example. Let's say we had, so n is the number of people, right? Let's say we had 200 people come to the party. That means that each person is going to get 1 cookie. Okay, so let's just throw out another number that's smaller than n, or sorry, smaller than 200, and let's do ones that are easy to work with. So let's say we had 100 people come to the party. Okay, so now we have 100 people come to the party. And if there's 200 cookies there, then how many cookies is each person going to get? Well, 200 divided by that 100 that we know is going to give us 2 cookies per person. Okay, let's do one more example. Let's say we had 50 people. Okay, so if we had 50 people come to the party and we have 200 cookies and we take that 200 cookies and split it or divide it by those 50 people, each person is going to get 4 cookies. So now let's look at the data that we have. As we look at that data, as our number of people decreases or gets smaller, what happens to our cookies? What happens to our numbers here on this side? We went from 200 to 100 to 50, and on the other side, the number of cookies went from 1 to 2 to 4. So one went down and the other one went up. That would be an inverse variation. So we'll just put an I for inverse. And the last part is they want us to go ahead and give an equation. So our equation, well, is going to have 200 involved because that's the original number of cookies that we had. So our cookies per person is going to be equal to 200, because that's how many cookies we have, divided by the number of people. So this would be an equation that we could go through and actually use. So we could substitute any number in for n. Obviously, if we don't want to have to be breaking cookies to share them equally, we're going to have to find numbers that would go into 200. or that 200 was divisible by. Okay, so let's go ahead and try another one. So letter B, you work at a restaurant for 20 hours. Let R represent your hourly pay rate and P represent the total amount that you earn. So no matter what, you're working 20 hours. So that's going to say it's not the number of hours that you work, but it's how much you're going to get paid per hour. So for example, when you work at maybe a grocery store or even as a nurse or anything like that, you have people, not everybody is getting paid the exact same amount of money in each shift. Some people are getting paid more money per hour than others because they've worked there longer. So here's an example of where everybody's working the same number of hours, but people are getting paid differently. So maybe we'll throw out, I don't know, 3 different price amounts. Let's do ones that are easy to multiply in our head. So let's say one person gets $7 per hour. Okay, and that's our pay rate we're represented by R, so they wanted us to use an R for that. I'm going to shift this up. And then P is going to represent our amount earned. Okay, so let's see. If we got paid $7 per hour and we worked 20 hours, because everybody's working 20 hours, well, 20 times our 7 would give us $140. Okay, so then we have the next person who's maybe worked at we'll say we're working at Fairway, who's worked there for a year, and they're getting paid $8 an hour. Okay, so they're still working for those 20 hours out of the week, so we're going to take 20 times our 8 this time, which gives us $160. Okay, let's say we have a third person on that same shift, and they work those 20 hours throughout the week, and this person's worked there for maybe 3 years, and they get paid $9 an hour. Okay, so now this time we're going to go 20 times 9, and that's going to give us $180. Now we could continue on as long as we wanted, but we have enough information here to help us decide if it's inverse or if it's a direct variation. So here, as your pay rate increases, so from 7 to 8 to $9, what's happening here? Are we increasing or decreasing? We're also increasing, so both of them are increasing. We don't have one going in one direction and one in the other. They're both increasing, so that would be a direct variation. So we're just going to put a letter D for direct variation. And now we need to write an equation. Well, what did we do every time? We took our rate of pay, our R, times 20. So we usually see that as 20R. We'll write it like this. And that's going to equal our pay, how much money we earn. So they had us use the letter P for that. So P equals 20R or 20 times R. And if you have it as R times 20, that's okay too. Okay, so let's try one more. And this one, I want you to go through and try to at least decide if it's inverse or direct variation. You're going on a 240-mile trip, so we're all traveling 240 miles. Let T represent the number of hours that you're driving, and S represent the speed of the car. Okay, so we're going 240 miles. Everybody's going 240 miles. Okay, so T is going to represent our hours, so that's our time, and S is going to represent our speed. So let's say I'm a fast cruiser, totally illegal, and I travel for 1 hour. And I have to go that 240 miles. So that means that I would have to go 240 miles in that 1 hour, so 240 miles per hour would be our speed. Totally illegal. Don't even know that my car could even get remotely close to 240 miles. Okay, so let's say I travel for 2 hours. And I know these aren't very realistic numbers, but it's okay. It's just going to give us an idea of what is happening with the numbers. So if we travel for 2 hours and we still have to go the 240 miles, well, 240 split into 2 hours, split by 2, is going to give us 120 miles per hour. Okay, let's say we did 3 hours. So we take that 240 miles and we split it out into 3 groups to see how fast we have to go in each hour. So 240 divided by 3 would give us 80 miles per hour. Now that's getting a little more realistic. Still probably a little bit fast, but we can at least see from here what's happening to each of our sets of data. So as our time increases, so we go from 1 to 2 to 3 hours, what's happening to our speed? So as the time increases, the speed goes down. We're going slower as our time increases. So this would be an inverse variation. Okay, and inverse involves division. So here our speed is going to equal 240 miles divided by the amount of time that we're traveling. Okay, so once again, we're just trying to give some examples of where inverse or direct variation may occur. Oops. Okay, so the last one. And I can actually, move this out of the way. Oh, my smart board's slightly off, so it's messing with me here. Anywho. Okay, so this is at the bottom or in the middle of page 85 of your book. So it says the wing beat frequency, so how fast the wings move, of a bird is the number of times per second the bird flaps its wings. So here they're giving us some pictures, and we have the hummingbird that has a 3-inch wing span or wing length, and a mallard duck that has a 12-inch wing length. The Canadian goose has a 28-inch wing length, and the albatross has a 52-inch wing length. So it says, which of the following seems true? Explain your reasoning. So what I want you to do is kind of take a break, read through these 3 examples that they give us, and identify which of these 3, so you're going to pick one, it's like a multiple choice, which of those 3 do you think is true when it deals with how fast the wings have to beat compared to the length of those wings? So the first one, you have the wing length and the wing beat frequency are directly proportional. So that means that as the length of the wings are longer, then that means the frequency is also a higher number. So they would have to flap their wings more often is what that means. The second one says the wing length and the wing beat frequency are inversely proportional. So as, for example, the wings get longer, then they mean that the frequency would get shorter or less times that they would have to flap their wings, or vice versa. As the wings got shorter, then the frequency would have to be higher. They would have to flap the wings more. Or the third one says wing length and wing beat frequency are unrelated. They have nothing to do with each other. So go ahead and take a guess as to which of these you think is the correct answer. The correct answer would be the second one. Okay, the longer the wings are, the more air they're going to be able to move out of their way, and therefore the less times they're going to have to flap those wings to be able to fly the same. Okay, so the shorter the wings, the more they have to flap those wings, and the longer the wings, the less they have to flap them. Okay, well that's it for lesson 2, activity for 3.8. Good luck with this, and just remember, inverse variation is when one gets smaller, the other gets larger, or vice versa, versus direct variation, which we discussed in section 7, is when they both move in the same direction. They either both get larger or they both get smaller.